Welcome to day 28 of our STL masterclass. Today we are taking everything we have learned so far, especially maps, strings, and algorithms, and applying them in a real-world mini project. We will build a text frequency analyzer, a compact yet practical application of STL to solve a very common problem in text analytics, understanding how frequently words appear in a piece of text. Let's explore how STL empowers us to solve this cleanly and efficiently. The goal of this mini project is to build a program that analyzes a block of text and counts the frequency of each word. Then it should display those frequencies sorted in descending order so we can quickly see which words appear the most. To keep it robust, we will also handle things like punctuation and case sensitivity, ensuring hello and hello are treated the same and punctuation marks don't break words apart. This is a great example of how STL makes such tasks seamless. For this project, we will bring together several STL components. First, we will use either unordered map or map to store word frequencies. Then, iString stream will help us parse the input text into individual words. For cleaning the text, like removing punctuation and converting to lowercase, we will transform and remove if. Finally, we will use a vector of pair string comma int to sort the results and display them. These STL tools combined allows us to build this project with very little boilerplate. Text processing is an essential step in any text-based program. First, we remove punctuation marks using remove if in combination with ispun punc. This ensures that symbols like commas, periods, and quotation marks don't interface with word separation. Then we use transform to convert all characters to lowercase, making our comparison case insensitive. Without these steps, we would end up with misleading duplicates like word and word being counted separately. Now that our input text is clean, we are ready to count the words. We use an unordered map where the key is the word and the value is the frequency count. We feed each word into the map using a while loop with an input string stream. If a word is seen for the first time, it's added to the map. If it already exists, its frequency count is incremented. This simple logic powered by STL turns our code into an efficient word frequency engine. Once we have tailed all the word frequencies, we need to sort them to find the most common words. Since unordered map and map do not allow sorting by value directly, we copy the map's content into a vector of pairs. Then we use sort with a custom lambda function to sort the pairs in descending order by frequency. This way the most important words appear at the top of the list, ideal for both display and analysis. With the sorted list in hand, we may also want to compute the total number of words processed. This helps us calculate word percentages or just get a sense of the text size. Using accumulate, we sum all the values, the frequencies from our vector of word pairs. The lambda inside accumulate simply adds each frequency to a running total. This one-liner STL trick is clean, fast, and very readable. We have now built a working word frequency analyzer, but there's a lot more you can do to level it up. For example, you can read the input from an external .txt file using if string. You could also filter out common stop words like da or is to focus only on meaningful words. Displaying the top 10 most frequent words or visualizing frequencies using ASCII bars is another great improvement. Finally, try switching between map and unordered map to compare performance in large inputs. This is a sandbox for experimentation. Here's a simple sample output from our analyzer. As you can see, the words are listed alongside how many times they appear in the text. This output can easily be formatted further or extended with bar charts, percentages, or color-coded highlights. Once you have understand the data structure behind it, enhancing it becomes a creative endeavor. To complete today's session, your assignment is to extend this project. Start by reading input from a .txt file and skipping commonly used stop parts. Then try to display only the top 10 most frequent words and include the percentage each contributes to the total. For those feeling adventurous, implement a menu-driven console interface that allows users to select options interactively. This assignment is your opportunity to integrate STL with real-world design patterns.